Welcome back, everybody. This is part 3 of 5 in my series on radicals. So if you haven't seen the first two, please go check them out now. In this video, we're going to use rationalization to remove radicals from the denominators of fractions. So let's get started. The first question that you probably have after seeing that intro is, well, why would I want to remove radicals from the denominators of fractions, Cole? And Cole's answer is, well, some people think it's bad form. Personally, I'm not so judgmental against it, but you may have future instructors that are, so I'm going to teach you how to properly rationalize your denominators. In other words, how do I rewrite a number so that it doesn't have a radical in the denominator? For the case of problems A and B listed here, it's actually pretty straightforward. I've got a root 7 in the bottom. I would like to clear that square root. But go ahead and pause the video now to see if you can remember from part 1, what is the square root the inverse operation to? Well, the square, right? It's the inverse operation to the square. So if I take the square of this thing at the bottom, in other words, if I multiply top and bottom by the denominator, I'm going to cancel that radical in the denominator, right? So on the top, we'll leave it be for now. On the bottom, we learned from the last part of this video that when I multiply radicals, I multiply their insides together. So I get root 7 squared. Well, the square root of 7 squared, that just cancels out. And I'm left with 6 root 7 over 7. See if you can try part B on your own. Fully simplifying, you just rationalized, you should have arrived here at 3 root 8 over 2. The way that we get there, again, is by noticing that radical in the denominator and then multiplying top and bottom by it, so that in the denominator, I'm just left over with the 8. Now on the top, though, I've got 12 root 8, and I have a factor of 4 that I can cancel top and bottom. That leaves me with 3 root 8 over 2. Well, root 8 can be simplified further into 2 root 2. And now the 2's cancel top and bottom to just leave me with 3 square roots of 2. In part C, this would still be considered bad form because I've got a radical in the denominator, but this one's not quite so simple to rationalize. Instead, we need to use a trick that's not at all obvious at first, called using the conjugate. Now, the conjugate of this denominator, 3 plus root 2, is just the same thing with the opposite sign in the middle. So I changed the plus to a minus. If I started from a minus, I would just change it to a plus. And this is the number that we want to multiply top and bottom by to rationalize our denominator. Let's see what happens when we do it. For now, I'm going to leave the top alone. We'll come back to that guy in a minute. Oh, and I can get rid of this arrow here now. On the denominator, I've got this big old ugly mess. But I can FOIL this guy out. If foiling is maybe a little bit unfamiliar to you or it's shaky ground, don't worry, we're going to spend a lot of time on it here in a little while. But basically what ends up happening is I get 3 squared plus 3 root 2 minus 3 root 2 minus root 2 squared. And on top, when I distribute, I get 15 minus 5 root 2. Now you'll see that all of the terms with the radicals cancel. And what I'm left over with is 15 minus 5 root 2 over 9, my square root and square cancel, minus 2, or 15 minus 5 root 2 over 7. Go ahead and pause the video here and see if you can come up with the next one on your own. Hopefully we were able to arrive at this conclusion. 4 times 3 root 2 plus 4, or 12 root 2 plus 16. But let's see how we got there. I multiplied top and bottom by the conjugate of the denominator. In this case, that would be 3 root 2 plus 4. Now you'll notice I used quite a bit of a shortcut in the next step. That's because, in general, when I'm doing this process, if I have the square root of a plus root b times its conjugate, I will always just get a plus b. And this is sort of a shortcut you can use for now until we review how to FOIL things out. So notice I got 3 root 2 squared minus 4 squared. And sorry, that should be a minus sign here. That leaves me with 2 in the denominator, which cancels with a factor of 2 up top. And I'm left with 4 times 3 root 2 plus 4, which simplifies to 12 root 2 plus 16. From this video, you should be taking away how to rationalize denominators. In the next video, we're going to look at how to extend this idea of a square root, which is the inverse to the square, to all sorts of other kinds of exponents. Catch y'all in the next one.